at 360 degrees, but also being enabling to project on other surfaces. So it can be on a table in the case of a meeting. And we had in total these 4 motors that can move, with one to track the user and the other one to select the projection surface. So we noticed that beamers are static and that they are not interactive. And we wanted to change this, to have beamers that we can interact with, to have beamers that can project at any places in the room, and to detect where are people. And for this we had to do a prototype.
Yeah, for the hardware, we needed to make this hardware really quickly because the challenge itself is 10 days and the hardware should be prepared as soon as possible. Like this, we can test the software as soon as possible. And so what I did, first of all, everything is made with a 3D printing, so like this, it's faster. And what I did, I designed, first of all, the system for moving the mirror. And afterwards, if you look carefully, the system for moving the camera, it's almost exactly the same, but just mirrored like this.
We started with some basic mapping, not using the Kinect, and then we eventually found techniques to use the depth camera to make that easier for us. So there is different challenges. There is the challenge of creating the odometry, of getting all of mapping the whole room, and there is the challenge of then adapting the projectors to the mesh of the room that we extracted.
And later on, to detect the users and to know where they are, and to enable this interaction through gestures in order to let the user decide about where to project. So it was the perfect team to conduct such prototype.